Hello everyone, today we'll talk about enzyme-linked immunosorbent also called Elisa. First, we need to know what's the Elisa. Elisa is a sensitive immunodeficit that uses an enzyme linked to an antibody or antigen as a marker for the detection of a specific protein, especially an antigen or antibody. The result could be confirmed depending on color product produced by reaction of a substrate with the enzyme. The technique involves following three principles. First, immune reaction and enzymatic chemical reaction and signal detection and quantification. There are a number of variations of ELISA. There are indirect ELISA, sandwich ELISA, and competitive ELISA. First, indirect ELISA. The indirect ELISA detects the presence of an antibody in a sample. The antigen for which the sample must be analyzed is adhered to the walls of the microcatheter plate. Then we add the sample. The primary antibody present in the sample binds specifically to the antigen. Then solution is washed to remove the unbound antibodies, and the enzyme conjugate the secondary antibodies are added. The substrate for enzyme is added to quantify the primary antibodies through a color change. So we can say amount of calories proportional to amount of antibody in patient sample. Next, sandwich ELISA. Sandwich ELISA is used to identify a specific sample antigen. Unlike indirect ELISA, the sandwich ELISA requires the target antibody, target antigen with two vectors. First, the walls of microdata plate are coated with the antibodies, and then the antigen-containing sample is applied to the walls and bound to the antibody. Unbound products are then removed by washing, and labeled secondary antigen is added. Hence, the sandwich is completed. Unbound antibody enzyme conjugate are washed off. The substrate for enzyme is introduced to quantify the antigen. So we also can say amount of calories proportional to amount of antigen in patient sample. Competitive ELISA. This type of ELISA depends on the competitive reaction between the sample antigen and the antibody and antigen bound to the walls of microcatheter plate with the primary antibody. First, the primary antibody is incubated with the sample, and this results in the formation of antigen-antibody complex. The antigen antibody mixture is added to the walls, which coated with the same antigen. After incubation and bound, the antibody are washed off. The more antigen in the sample, more primary antibody will bind to the sample antigen. Because antigen-antibody complex couldn't bind with antigen coated on the walls, so there will be smaller amount of primary antibody available to bind to the antigen coated on wall. Next, the secondary antibody conjugate to enzyme is added, followed by a substrate to elicit chromogenic signal. And like the other two ELISA, The concentration of color is inversely proportional to the amount of energy present in the sample. Today we'll see how to use the sandwich ELISA for detecting the presence of hepatitis B surface antigen from a sample of body fluid. There, there are the reagents what we need for the assay. And these are the general procedure of ELISA. And each have 5 major steps. Step 1. Coat the plate with capture antibody and wash the plate 3 times. Phase 2. Specific binding and antigen. We add 100 ml of sample and standard control. Positive control, negative control, wash buffer for aspartame and sample are added to the wires of plate from left to the right in sequence. Its specimen is tested in duplicates and the incubation plate at 37 degrees Celsius for 30 minutes. After washing, step 3, enzyme labeled antibody is added to the vial and 100 ml per vial, except the empty vial. Then incubate at 37 degrees Celsius for 30 minutes. Next, we need to read the result. First, we need to add the substrate to the vials and then keep in dark for 10 minutes at room temperature. After 10 minutes, we add stop solution, and then measure the result. Next, I will show you how to do the test. Now list the laser plate coated with capture antibody, and we take one strip of plate containing 8 vials, and then we will add a sample to the vials from left to the right. 100 ml per vial, and we start with filling the first 2 vials with positive serum. And the next 2 vials with negative serum. Another 2 vials with wash buffer as blank. The last 2 vials with sample for detecting. Then we put it in a humidified box under 37 degrees Celsius. After 30 minutes, we take out the plate, and next we need to wash the plate. First, we discard the liquid and add water buffer to the plate, not too much, avoiding overflow. Stay for 1 minute. After 1 minute, we decant the solution and blow on the clean dry paper towel. And we repeat the washing. After 2 addition washing, then we add 100 ml enzyme labeled secondary antibody to each vial, except blank vials. And we can see there is no enzyme labeled antibody in black vials. Next, we wet bath for another 30 minutes and 37 degrees Celsius. When the incubation is over, we wash the plate as previous. After washing for 3 times, then we add the substrate. We had substrate A and B. First, we add substrate A 1 drop per vial. Then we add substrate B in the same way. Also 1 drop per vial. Drop. Okay, then we put the plate at room temperature in the dark for about 10 minutes. After 10 minutes, we can see the positive control and the sample is blue, while the negative and blank is colorless. And this indicates the sample give a positive result. Then We add stop solution to the wells and to drop a well. After adding stop solution, we can see the liquid in positive and sample positive control and sample wells should change from blue to yellow. Then we can analyze the result by spectrophotometer. We can analyze the result by two ways, by naked eyes and by spectrophotometer. First, let's see how to analyze the result by naked eyes. If the negative control and blank wells are colorless, but the liquid in sample wells show a bright blue color as positive control. We can see the sample give a positive result. Then let's see how to detect the result by spectrophotometer. First, we need to add stop solution. Then the color of the solution in the positive control and sample wells change from blue to yellow. And next, we read the absorbance at 460 nanometer by spectrophotometer. And if the ratio of optical value of sample to the optical value of negative control is equal or greater than 2.1, it means the sample gave a positive result. If less than 2.1, it means negative. Last, we need to finish the report on paper. And the report includes the title, principle, result, and conclusion. Now, let's see how to write the result. First, we need to make a table, and this number is the number of the wells, and then we write the color of the negative, of the positive, negative, blank, and sample in here. And in the demonstration, we can see the color of positive and the sample is blue. So we write blue here. And the color of negative and the blank is colorless. It means the sample gave a positive result. And because the test is intended to detect the presence of hepatitis B surface antigen, so the conclusion we can say the hepatitis B surface antigen test is positive. Okay, the class is over and thank you for your attention.